All right, so here we have another problem. This is a statistics problem. 6 men and 7 women apply for 2 identical jobs. If the jobs are filled at random, find A, the probability that both are men, and B, the probability that 1 man and 1 woman are hired. All right, so the first thing that I like to do when I do problems like this is I try to figure out what is the total number of ways I can rearrange both a man and a woman in these 2 slots. Okay, so it is not, I know what you guys are probably thinking, it is not 7 times 6, okay? First of all, that's a low number, 42. And second of all, this is actually going to help us with part B. The meaning for this is um, is the number of ways you can arrange a man or a woman, in this case, because it's 7 women, is the number of ways you can arrange a woman in the first slot and the number of ways you can arrange a man in the second slot. This is what 7 times 6 means. So this is not the total number of ways I can arrange both a man or a woman in 2 slots. That is going to be 13 combination 2. Now this is what the number of ways you can arrange a man or a woman in both slots. This is going to equal 78. We're going to skip the whole, I'm not going to show you guys, I could show you guys what that will look like if you were to do it manually. That's 13 minus 2 factorial times 2 factorial, but that'll take way too much time to do. So that's why I encourage you guys, if you have a TI-84, if you don't, buy one. Because it will help you out a lot, especially if you're going to take your SATs or your praxis exams. All right, so that's the total number of ways I can rearrange a woman or a man in those 2 slots. Now I need to figure out the ways I can arrange a man in those 2 slots. So the way I can arrange the 6 men in those 2 slots is just 6 combination 2. And that, I believe, is 15. Yep, 15. So now all I have to do is put, this is what it'll technically look like, but you'll have 6 combination 2 as your numerator and 13 combination 2 as your denominator. And that'll be 15 divided by 78. And that is going to equal 0.192 or 19.2%. And now let us do part B. Let's do B in green. Part B is the probability that 1 man and 1 woman are hired. All right, so just like I said in the beginning of the video, it's going to be 7 times 6. That's the number of ways I can arrange a woman in the first slot and a man on the second slot. So all I have to do is divide that by the total number of ways I can arrange both a man or a woman in those 2 slots. That is 13 combination 2. It's still 78. So that's 42 divided by 78. I believe it's like 53.8 if I'm not mistaken. Yep. 42 divided by 78 is equal to 0.538 or 53.8%. And that is how you do this problem. If you like the video, I know I'm going to be posting a lot more probability and statistics problems, because I feel like these types of problems are probably the hardest ones in statistics. So I'm going to be posting a lot of these. And by the way, this problem was taken straight out of the McGraw-Hill Elementary Statistics. If you're having trouble, find a way to get that book, Elementary Statistics, because it will help you out immensely. Trust me, that book explains in detail a lot of examples. And I've actually seen certain examples on the praxis exam and that are in this textbook. So I would encourage you guys, and also in the SATs. So I encourage you guys to get this textbook if you're having trouble with statistics. If you like the video, please give this video a like. If you want to see more videos like this, subscribe to my channel and hit that notification bell button to be notified when the next video is up. And I'll see you guys in the next one.